На английском, правильно? Hello everybody, my name is Evgeny Kucheravi, and today I'm going to talk about artificial intelligence and 5G, basically when AI meets 5G and where the story begins. And we're gonna talk about this artificial intelligence in general and 5G networks in general, and how those technologies can be applied or will be applied in the megacities. As far as we know, currently the world develops towards the agenda when people are moving from the villages and small cities to big conglomeration of the cities, or forming one single megacity where we have a large number of population varying from 10 million up to 30-40 million. And already now, as you can see on the right side of the slide, on the Earth we have about 33 megacities, and the number of those megacities is increasing rapidly, and in coming decades we are expecting another 6 megacities to be formed by 2030. So basically in 7 years it will be increased, and not only in Asian countries but also in Europe, in America, in Latin America, in Africa, Middle East, etc. So then what's going on in those megacities? We live in Moscow, and we know that the megacity, every megacity has a large number of problems, but those problems are mostly connected to the lack of communication between different services, between different components of the city. And basically, if you are able to design a megacity in a so-called Lego blocks, where every problem can be addressed internally inside of the box, and then through the interface you can send information to another Lego block of the megacity, so then you can basically solve the problems. And those mega blocks are basically developed based on the smart city notion. And as you know, in a smart city we presume that many different components are communicating to each other through the communication facilities, meaning that through internet and through the fixed network and through the wireless network. And well, in the megacity we always have a large number of people, and all people are communicating to each other using regular mobile phones, through the GSM channels, and then they also communicate through the data channels by the sending of the messages and voice calls over, for instance, WhatsApp, FaceTime, Viber, and many other applications. And people create a huge amount of traffic. But in smart city, that's not the key point, since in a smart city we presume that many different components, such buildings, such infrastructure, cars, vehicles, they start to communicate to each other and to the people using special services. For instance, like Uber. Uber gives an opportunity to call for taxi for a person that has a connectivity via smartphone. So then also the cars are coordinated through the intelligence that is located on the cloud side. So basically then we are having the communication between devices. That's the best example at this stage can be given. However, in 2-3 years we will be facing the new challenges when buildings and infrastructure such as bridges, such as the roads and traffic signs, traffic lights will be communicating to each other and to the outer world. And then we will be able to see the so-called Internet of Things agenda deployed in the smart city. So then, on this slide, I have a brief picture that gives a large, a big view on the different sectors of the Internet of Things applications and future wireless network use cases. On the left top side of the slide, we see the urban sector that features smart city, network, mobility, etc. On the top right, we see suburban sector where a lot of population live. For instance, if we take a classical US megacities like Los Angeles, for instance, there is a very small downtown that has a number of skyscrapers and business center, and then most of the people are distributed over the suburban sector where they live, and basically commuting sometime takes like 2-3 hours to the downtown. So then on the lower right side, we see rural sector with environmental monitoring, organic agriculture, green energy, etc. So basically the area where we expect to have agriculture developments that will supply food to the suburban and urban sector. So the last but not least is industrial sector. That is a very important component of the future megacities. Some people say that the factories will be inside of the megacities. Some people say that the industrial sector will be outside of the megacities. My personal opinion that it can be both. And take into account industrial sector, we can talk about automation, robotization, sustainability, and productivity. So altogether, we see all the areas where the Internet of Things or future wireless network use cases are applied. So basically then, inside, in the center of this slide, we see the more detailed information on the sectors where the IoT and future wireless network use cases will be applied in healthcare, consumers, smart buildings, utilities, agriculture, environmental, industrial, transport and logistics, and smart cities. So then, if we zoom into this puzzle of the smart city and the suburban and rural and industrial components, so we can see that in every case we have a number of different applications, challenging applications that basically make our life better, easier, and more sustainable. So if we start from the top left side of the slide, so we can see the VR glasses, so we can see wearable device, we can see smartphone, and it's called altogether handheld and wearable devices. So basically at this stage we have those three types of the devices. However, as you know, many things are coming in the area of smart wearables, smart clothes, when basically your t-shirt or your jacket can be connected to the network, can be connected to the intelligence, and then it may act as a sensor for the different types of challenges. For instance, wearing a smart jacket outside, you can easily measure CO2 of the on a street from one hand. From another hand, you can use that smart clothes as your personal health monitoring. And then we are moving to the top right side of the slide, where we have like outside of the body, inside of the body connectivity. And as you know, health is a very important component of the megacity, of the smart city, and that is one of the most challenging thing for the humanity, because every human wants to live longer, healthier, and with less health problems. And at this stage, we see, especially in developing countries, the birth rate goes down, and the average life expectancy goes up. And that basically the result of the over last several decades, the developed countries introduced healthcare that is targeted on the duration of the lifetime. So basically, the person is considered to be an asset, and then you basically succeed when a person lives longer. However, as we know, at this stage, a lot of people live beyond 80 years, 90 years, but their life is not that happy as they would have, because most of the people older people spending a lot of time in the hospitals. However, as you may think that you don't want to spend your elderly time in the healthcare centers, right? So you want to live full life at home and going outside, talk to your kids, your grands, meeting friends, etc. So meaning that the challenge in the healthcare is to improve the lifetime and to decrease the time that a person spends in the hospital. That gives a new challenge that is addressed through the wearables and implanted devices. So altogether, those implantable and wearable devices are targeted on the decreasing of time a person spends in the hospital, meaning that the person's health can be tracked all the time and with a high reliability. And if something happens, so then person can be admitted to the hospital. Otherwise, person spends time at home and in the city. So that's a huge challenge where a lot of money are invested onto. So then we have the consumer devices, consumer IoT, Internet of Things. Basically, it spans from the personal transportation systems, as you can see in the circle. So then the measuring of the different consumption things such as water, such as electricity, that can be directly reported to the provider, and they can charge your account. So then also some other smart home appliances, smart home implementations that generate a lot of data that can be used to improve the lifestyle of the people. So then the industrial IoT component is very important since industry basically pollutes the planet, and we are currently in the pressure from our politicians that we need to reduce consumption and we need to reduce the footprint that is human being practically set for the planet. And on the consumer side, we can do that by reducing of the usage of the combustion engine cars, moving towards electric cars, moving towards car sharing paradigm. For instance, in Moscow, we have one of the top car sharing statistics. Over the last 3 years, we achieved around like 10% of the drivers are using car sharing instead of using of the own car. That's a top figure on the global scale. So then we also need somehow to change the energy generation habits. That can be done on the industrial side. All types of the wind generation technologies that are capable of the producing of energy instead of the well-known coal-based energy or nuclear energy. Then we also have an opportunity to use different type of manned and unmanned aerial vehicles or drones, in other words, to bring different type of the values compared to the existing business models. For instance, as a simple example, that delivery of pizza by the drone can easily save a lot of the CO2 emissions compared to the moto or the car delivery of pizza. So then, obviously, the industrial sector, as I told you, produces a lot of bad things to the nature and to the people, and we somehow need to optimize that. And basically, industrial Internet of Things gives an opportunity to decrease the amount of waste energy, decrease the amount of emissions, different type of emissions, by the optimizing the processes using digitalization of those processes. For instance, if we have batteries, industrial batteries that are huge, like several hundred kilos, batteries that basically cost 10,000 euro or even more, and those are not connected at this stage. So we charge, I mean not we, but in the industry they charge those opportunistically, and they don't know what's going on with the battery. By simply connecting those batteries to the internet and put onto the cloud all the statistics of the industrial battery, we are able to decrease to increase the lifetime of the battery by 30 to 50%. So that you can imagine then we need to produce less batteries, we need to dispose less batteries. That obviously influences significantly to the smart city and mega city from the emissions point of view. So to wrap up with this slide, I just have to say that there are a lot of things that need to be optimized in the megacity, because megacity has a lot of population, a big number of different vehicles, different factories, big number of the blocks, apartments, and houses. So if we compare different megacities in different countries, for instance, let me say like Tokyo in Japan, and sorry, I have the message that sound is somehow horrifying. I have a message that sound goes well, and probably you need to adjust the connection or the speakers on your side. I'm sorry for that inconvenience. So if we compare that Japan, Tokyo megacity, for instance, with some megacity in Bangladesh or India, that might be a big difference, because at this stage, say in less developed countries, we have more problems on the emissions, on the introducing of the IT technologies, comms technologies, etc. However, as far as I know, in India, for instance, in Africa, there are a number of governmental programs that are targeted onto the digitalizing of the smart cities and megacities in order to get much better lifestyle for the people. So all of you are using smartphones, and most of you are having 4G sign on the bar, on the top bar, and you know that 5G is coming. And what is 5G? 5G is not just simply another generation of the wireless network. It is a new paradigm that gives us an opportunity to have a network dedicated for the different types of the services. For example, nowadays we have a regular 4G network that its rate is up to 1 gigabit per second, and delays are, well, quite substantial sometimes. And 4G network, and LTE in particular, was designed in order to transfer, to support transferring of the streaming network. Traffic, streaming traffic that we are generating on our smartphones. For instance, if somebody wants to have a video call or a YouTube video, everything is just streaming. So we need more capacity, we need less latency, however not that super ultra low latency, just latency that allows us to run the stream. In 5G we have a number of different types of access networks that are basically designed to support different type of traffic. As we know from the previous slides, IoT, Internet of Things, is just a technology that sends a small chunks of data between a sensor and the base station. Obviously, if we start to use LTE for the purposes of sending of small chunks of data, it will be highly inefficient. It will be just a disaster for the network, because then to establish a connection we need to spend some time, to close the connection we need to spend some time, and everything is just for the sake of sending a small chunk of data. While if you send the stream of the data, you also establish connection, you close the connection, but in between you send a lot of data. So it's highly inefficient. In 5G, we got the technologies that allow you to send small data in a very efficient way. Moreover, it is targeted also on the ultra-low delays, and I will follow up on that on the later slides. On this slide, you can see the also the difference between current 4G or LTE networks on the left side and 5G evolution. As you can see, the amount of base stations becomes larger, the density of the base stations and correspondent number of the devices which are connected to the base stations becomes also larger, because as we spoke, we have a large density of the population in megacity. We have blocks of houses, we have office houses which are basically equipped with different sensors, equipped with laptops, computers, etc., etc. So we have a very high density of the networks. For instance, if today you hit the traffic jam in Moscow or in Tokyo or in Dhaka, in other megacities, you may experience very slow internet access. Why that? Just because we are too dense, and all of us who are sitting in the traffic, we would like to get an entertainment. We would like to read emails, we would like to watch some movies or some YouTube videos, etc. And when all of us hit the limited bandwidth, we just need to share it somehow, and every guy gets just a small chunk of the bandwidth that is not sufficient to feed all the our wishes into that small chunk of the bandwidth. In 5G, we have a much larger bandwidth, and we have a smaller distances to the base stations, and meaning that we have a higher capacity for the our traffic, and that gives an opportunity to connect our cars to the 5G networks with a very good efficiency. As you know, some of the car manufacturers already now provide connectivity to of the car to the network. For instance, Tesla comes with a subscription. So then BMW, Porsche, Volkswagen, they also start to provide subscription. Not exactly necessary at this stage, but they're going to introduce compulsory connection to their cars. Meaning that in a pretty short future, most of the cars will get connected. Cars per se, not only the passenger or the driver, but also the car. So then car will be an entertaining center for the passengers, but will be also used as a storage device for the data, for the catching of data, and it will be used at the base station location, because in a car we don't have any problems with the electrical supply, right? So we can easily put up access point into the car and then have the opportunity to serve other cars around us, passengers, other pedestrians, and even the smart infrastructure like smart building, etc., etc. So as I spoke, here's a very good example where we compare one service, all IP broadband connectivity via phone, that is on top for the 4G cellular networks, voice, text, mobile, internet, IoT, everything comes through that at this stage. In the color picture that represents 5G cellular networks, we see that there are three basic classes of the services. We see this EMBB, it's just the same as we are currently using enhanced mobile broadband service for the different types of the streaming through the personal device, through the network of personal devices, etc. So then we have a special class of the communication connectivity, it's called URLLC, ultra low latency connectivity. That for the cars, and I will be speaking about the connected cars later on, but the general idea here is that if we will be able to basically assure super fast connectivity between every car and a network, so then basically we will be able to have the intelligence of the car transportation inside of the network, and then it will be easier to design the autonomous car. Because for instance now, if we have autonomous car, for instance Tesla is a good example, it just has a number of sensors in its body that controls the outer space of Tesla, and basically everything is calculated on board of Tesla, and all decisions are made on board, meaning that basically car is not aware about other happenings which are behind the corner, right? But when all the cars will be equipped with this ultra reliable low latency communication, meaning that the network side will be knowledgeable about cars, all cars in some geographical areas, their speeds, their location, and can coordinate the cars which don't see each other. So basically then intelligence goes towards the network and decision is made on the network side, or at least it will be point of the collection of data and then send the data to the car, so you can still have a decision on the car side if you drive it, for instance, yourself, but you will get the notification that, for instance, you got some kind of the crazy car approaching to you on the cross, and you don't see that. So then the bottom service, which is in red, metering agriculture climate, that is MMTC. This is mobile type communication that basically gives us an opportunity to install up to 200,000 devices per square kilometer, devices which are sensors, which are transferring data not that often. For instance, if I have a say electricity meter in my house, well, that would be pretty enough for my electricity provider, for the grid provider, to read that meter once per several days, for instance, or even once per month, when that the bill should come, and then that information can be sent to the information collection center. And if that information is lost, no problem, it will be sent just in 5 minutes or 10 minutes later. So nothing will happen with that. It's not a critical application, just a metering. So then, from other hand, all of you know what is artificial intelligence, and just I took a wiki definition on that slide, and basically in very short words, that it's a simulation of the human intelligence processes by machines, especially computer systems. These processes include learning, reasoning, and self-correction. So basically it's like a human. You can study the thing and then you become an expert. Same for the algorithm or the neural network that studies examples and then makes conclusions in the real life. So when we connect artificial intelligence and 5G network, we can see that basically from what I spoke before, artificial intelligence can be easily applied in the cloud of the 5G. 5G gives an opportunity to collect information, and then artificial intelligence should be able to make to analyze the data and make decisions based on those data. And that also quite important and quite interesting that we currently are producing and consuming content through our devices. So we can use Instagram or Facebook to, for instance, produce a content, and then our friends and other people consume that content, right? And that content is kind of the content that has no context, right? So we try to introduce the context by the putting hashtags like my birthday or meeting friends or anything like that, or by the putting geotag, right? But when we are able to collect a lot of information about the same happening on the same geographical area, for example, like what I just told you about the cars, so then we are going to have a context-based information retrieval. So cars would have an interest. What's the current environment? What are the cars around that there will be no traffic jam, or there will be no accident, or there is a card that brings a chunk of the data that my consumer will be needed in 1 minute. So then that chunk of data will come in 1 minute, and I knew that, so I didn't ask for the chunk of data from the distant server. It was brought to me by another car. So basically, artificial intelligence as a tool to analyze context can bring the same services new added value and make those services dynamic and reliable. Using data and artificial intelligence, we will enhance the just wireless pipe we are currently having between consumer and content. So basically, there are a lot of different technologies which were designed over the last decade, which are currently enabling this type of the AI plus 5G context-enabled services. Those paradigms are called mobile edge caching, context-aware networking, big data analytics, location-based services, and mobile edge computing. And from the operator's point of view, as you know, those guys are experiencing currently some problems because at some point of time they lost the opportunities because they didn't want to face the challenge of the content generation. If we go back 10 years ago, every mobile network operator was nice and happy because they were selling mobile phones and mobile subscriptions, and every subscription they collected like hundreds of dollars for the just GSM calls, minute-based or package-based, it doesn't matter, and they were happy. But then data communications arrived, and they invested a lot of money, introduced data, 3G, then 3.5G, and now 4G. But the major problem that operators, they lost the game on the content. And who won? Basically Google, Facebook, LinkedIn, YouTube, etc. Because at some point of time, like 5 years ago, we had not we, but operators had the following challenge. Operator needs to update the wireless network because customer wants to have a faster connection, better connection to the content. And content was provided by the content provider. And operator was just charging the money on the flat rate for the data. Meaning that it doesn't matter how much data operator will be transferring, it will get the fixed amount of money. And nowadays in some countries the flat rate went so down that operators are not able to capitalize on that anymore. For instance, reasonably speeded flat rate 4G in Finland costs €20 per month. And well, it's flat rate with 7 gigas limit. And operator gets nothing from the content. But luckily those guys realize the problem and they start to get deals with the content providers, etc. But they still are not happy with that because they need to upgrade their 4G networks to 5G networks, and that's a lot of pain because 5G networks, they need not only software upgrade but also hardware upgrade. You need to install new base stations, physically new base stations on the place of the old base stations, but also, as we saw, many new base stations need to be installed in a dense manner, and that's capital and expenses that operators need to carry. So that's why they need to understand who will be paying for the services, who will be paying for the access that they will get reasonable revenue of investment within like several years. And basically inside of the megacities they have a lot of customers, people. So then another strength for customers, transportation, another strength for customers, smart city and government, and then waste management, for instance, and optimized transportation, etc., etc., etc. So basically operators are also getting momentum and they need to introduce new services and get new added value out of those services. Otherwise they will get lost. At this stage we don't have yet 5G rolled out, but it's around the corner. The first rollouts will start at the end of this year, and the more massive say that within a year and a half we will be having a pretty decent number of 5G rollouts around the globe. And obviously the first rollouts will be performed in not in rural area but in cities, in megacities, because many more subscribers and business opportunities are in megacities. At this stage, vendors, the companies who are producing equipment like Nokia, Ericsson, Huawei and others, they are struggling on the implementation of AI for the 5G in order to keep up their network the best compared to their competitor. On the front playground is a radio resource management and mobility management, meaning that every device, even nowadays, collects information about the signal strength, the bandwidth availability, delays, etc., etc., at every point of time, and then sends that information to the operator. Then operator collects information and makes own conclusions. Then also definitely operator sells a lot of data which are not personalized in order to improve, for example, the shop placement or improve the connectivity, etc., etc. And they sell also data to the government in order the government understands how people flow inside of the large city. But that's what we have now. With 5G, vendors would like to have a real-time feedback from the network in order that every device that is measuring information sends data to the network, and then network in a real time commands the device what device needs to perform in order to fulfill the connectivity of all devices which are currently engaged into the connectivity for that particular base station, for that cell. Then I can give you an example of the 5G, complicated 5G agenda that is be deployed due to 2-3 years from now, where we basically have UAV or drones as a base station. So you can see on a picture a drone that is UAV base station. So then we have COW BS, this cell on wheels base station, as I told you, the base stations which are deployed on the cars. So then we also have people who are moving around, and that type of the scenario is envisaged by the 3GPP, the standardization organization for the LTE for the 5G, to be deployed in the areas with an extremely high concentration of the customers, of the consumers. It can be a city or it can be a stadium where basically you don't have a large connectivity all the time, but when you have a lot of people downtown or in a stadium, you need to provide extra connectivity. So basically you can see that we can send a UAV that has a base station and that gives extra capacity for the traffic that goes between cell on wheels, the base stations which are installed on the cars, and UAV. And then the people who are consumers who are roaming around, so they can have the traffic going through the cell on wheels to the car, then it goes to UAV, and then it wirelessly goes to the base station that is installed on the some building. As you can realize, all those components, people, cars, drones, are moving, and that is highly dynamic system that is pretty difficult to coordinate, because when you coordinate the things, you need to get the information about every participant in real time. So basically, that's the idea, that this AI for the radio resource management can be deployed on the site of the base station that is deployed on the building, and then all the information about all people, all car, cells on wheels, and UAV condition will be in real time streamed towards the AI intelligence in the base station, and then base station will be controlling UAV, cell on wheels, etc., etc. So that's the pretty complicated but pretty representative example that gives us the understanding why an operator needs this real-time communication between different stakeholders of the communications. So then, as we know, AI itself is a very well-known agenda, and it stems from the statistics that was under development from like 40s, 50s, 60s last century, and the neural network algorithm design was originally laid down back to also like 40, 50 years ago. And I recall when I was a schoolboy 30 years ago, I was programming with old computers. I was programming neural networks back 30 years ago from now. But now we have that on the market based on as a artificial intelligence, and the approaches can be used for the 5G networks are supervised learning, unsupervised learning, and reinforced learning. So let us check step by step which type of learning can be used where. Supervised learning can be used for different type of the 5G applications, mostly on the radio resource management. And as we know, supervised learning is the case when each training example has to be fed along with the respective label. And the notion is that training a learning model on a sample of the problem instances with known optima, and then use the model to recognize optimal solutions to the new instances. So as we can see from this table, the supervised learning model can be machine learning and statistical logistic regression techniques, then support vector machines, then neural network based approximation, supervised machine learning frameworks, and artificial neural networks and multi-layer perceptions. And on the right side, you can see examples for the 5G based applications. As I told you, at this stage we can talk mostly about the operator driven and vendor driven apps, while the smart driving, for instance, is the step, and we will analyze what is needed for the implementation of that step. So then the next one is unsupervised learning, where the training data is unlabeled and the system attempts to learn without any guidance. And the learning model can be Cummins clustering, Gaussian mixture model, expectation maximization, hierarchical clustering, unsupervised soft clustering, machine learning framework, affinity propagation clustering, etc. And as you can see, that's also about 5G based application for the operators mostly. However, different types of apps, mostly directed towards reliability of those networks. So then the next one is reinforced learning, where the philosophy of that type of learning is based on the learning system, often called agent, that reacts to the environment. And then the agent performs action and gets rewards or negative rewards or penalties, in other words, in return for its actions. As we can see, the learning models are listed on the slide, on the table. So then it's reinforced learning based on the long short-term memory cells, then gradient follower, and reinforced learning with network-assisted feedback. So then for the apps, again, it's mostly oriented for the 5G operators, for the operation of their network. And as we can see, some resource allocation, like proactive resource allocation, the selection of different radio access technology. This selection means that, for instance, today you have a mobile phone that has Wi-Fi, LTE, Bluetooth at least on the board, and the 5G phone will have also 2-3 more wireless technologies, and you are able to transmit your data through different types of technologies, or to use one technology or several technologies. For instance, if, for instance, you send data directly between your cellular devices, your smartphones via Wi-Fi direct, you can do that with coordination through the cellular network. So basically, signaling and coordination is done via the wireless interface that goes to the LTE network, and then the actual data are transmitted through the Wi-Fi direct. I already spoke a bit of time about the automotive and about self-driving cars, and that is considered to be one of the most important thing for the smart city and megacity, because, as we know, transportation and logistics is one of the most important and cornerstone of the megacity, of the smart city. Why? Because we got a number of things out of the organized transportation. For instance, when we speak about Beijing, most of the time we speak about the awful traffic and foggy air because of pollutions. Yes, indeed, I visited Beijing myself, and I experienced that type of the disaster. But for instance, if we manage to organize transportation in the proper way, so then the fog will melt out and the amount of CO2 emissions will go down. So then the health issues will go down. So like the amount of cancer cases is expected to go down. So then not only CO2 but also coordinated transportation in smart city will finally deliver shorter commuting time, so people can commute to the longer distances and easier than before. That will definitely increase the happiness of the people, and by putting entertainment systems into the coordinated transportation systems, we will have an opportunity to let people not only entertain themselves but also like implement life learning paradigm as an example, etc., etc. And obviously for that we will have to implement collaborative driving, collaborative awareness, context-aware vehicle distribution and coordination, and etc., etc. So that is one of the top components that, for instance, in Moscow we are up to, and a lot of money, governmental money, are introduced towards the optimization of the transportation system, because that is a cornerstone problem. And then the AI and 5G smart city integration. And as I spoke in the very beginning, on the very first slide, I told you that the smart city or mega city cannot live without connectivity, because smart city is built upon the connectivity between different stakeholders. And we cannot organize clever waste management, optimize transportation without connectivity. We need to have connectivity. But then we should have also the logic. We should have a decision maker that is anticipated. Artificial intelligence will do that. And current content-based services will go to the context-based services, and it will allow better life quality and less footprint. For some of you who have an engineering background, that slide might be of a bit of interest, because it gives you the brief overlook on the implementation details of the AI in 5G systems. On the left bottom side, you can see that we have a RAN controller, radio access network, meaning that we have different types of the access points. For instance, Wi-Fi access point, then we have LTE access point. In 5G we could have a new radio access point, that is cellular technology. We could have a WiGig, this millimeter wave access point, etc. So we coordinate by the controller the operation of those networks, right, wireless networks, and make those transmission efficient, take into account what is needed to be transferred and how and when, etc., etc. So then we up on the top we have the user allocation, scheduling, power control, make everything efficient, because currently we have several millions of base stations on the globe, and more millions to come. And every base station consumes energy and generates energy. Every base station has batteries as a recover. Every battery need to be disposed after 10 years lifetime. So it need to be highly optimized. Otherwise, by introducing new technologies, we will kill the world. So then we have the backbone network controller that is connected to the AI center, artificial intelligence center, that you can see in the middle of the screen, and that is doing sensing, mining, predicting, and reasoning. And then everything is all the data then transferred either to the wireless network, to the global controller or to the core network controller, where we have routing, caching, safety, and we have all the gateways, switches, middle boxes, and clouds. So now we are on the conclusion slide, and I would like to say just a few words by repeating certain things that we already have discussed, that artificial intelligence plus 5G is a promising combination for the megacities, where connectivity and corresponding services are the key enabler. However, we have 5G in its infancy, and by the way, AI also in its infancy from the practice point of view. However, 5G is progressing fast. Dedicated barriers, meaning that different types of services for different traffic, and low delays are available from very beginning, meaning that 5G base stations that will be installed by the end of this year will have this functionality already there. Ultra low delays will be achieved fairly soon, like within 2, 3 to 5 years. And that will enable for this context-aware, for instance, autonomous driving, as we have discussed. AI is well developed in theory and practice, but not in the telecom services. But they will ramp up. So, making the general conclusion that AI and 5G is not yet on the market. Nevertheless, the revolution is expected within 2-3 years from now. And still, architecture of the solutions need to be designed, and dedicated platforms need to be built. To my best knowledge, to my best educated knowledge, those dedicated platforms are currently under construction in-house of the different vendors of the telco equipment, such as Nokia, Ericsson, Huawei. So at this stage, I would like to wrap up this lecture, and thank you so much for your attendance, and you have an opportunity to ask your questions in chat if you wish. Thank you very much. Oh, very good question from Sangam. How we plan to tackle privacy and security requirements moving forward? Indeed, this is a top question of the privacy and security, because we are going mobile, nomadic, and more information is accessible through our device, a personal device that is currently has everything from our credit card numbers, our picture, face, up to our preferences in online shops and transportation modes, etc. I have to say that privacy and security need to be tackled from one hand separately, from another hand well integrated, because to my educated knowledge, currently privacy and security issues are addressed by the isolated solutions done by professionals, which then integrated into the solutions for the connectivity, for the different services, etc. But and that will continue, because if you can imagine, if something would happen with the smart city, and if an intruder will manage to get not only the data copied from the say nuclear power plant statistics, but then if an intruder will be able to to send data, to replicate data, to fake data, that is the super dangerous. And I can give an example. For instance, the current R&D agenda of the Europe on the 5G networks contains security as around 30% of the whole budget of the R&D activities. So you can see that, and say that 10 years ago it was not that bad. It was probably like 5%. As you can see, the privacy and security problems are on rise, and they will be more and more important with the coming years. Thank you, and if you have more questions, you are welcome again to use the chat. You're welcome, Sangam. Well, I don't see any questions unless somebody is typing in a big question. If you want to ask the question, please type in that I have a question, and then we'll wait for you while you will be able to type in the whole formulation. So at this stage, I don't see any questions coming from anybody. So then I presume that that's all for today, and thank you so much once again for attendance. I hope you grab some information that is interesting for you and in your education and your plans on the employment. Thank you so much. Bye.